In this video, I'll solve a problem involving a collision between one car heading north and another car heading west. In any collision, the place to start is with momentum. So momentum is conserved in any collision. I've drawn a picture of it here. So we've got a car coming from the south going north, another one coming from the east going west. There's a collision, and I'm pretty sure they're going to go off somewhere that direction. So I've drawn a final velocity arrow here, but there's a question mark on it because I'm not really sure where it's going to go. I've listed out the knowns here and the two things we need to find. It asks for final speed and direction. So VF, that's the final speed. The two vehicles stick together at the end, so we don't need a V1 final, V2 final. It's just one V final. And then also the direction. So conservation of momentum says the initial momentum equals the final momentum. In this case, remember these are both vectors, we have this direction momentum and that direction momentum. So we can solve each of those separately. So P initial in the x direction, if I call this plus x plus y, so P initial in the x direction is P final in the x direction, and P initial in the y direction is P final in the y direction. So P initial in the x direction, that would be this way. It's M1 V1 initial in the x direction plus M2 V2 initial in the x direction, except that car 1, if we call this one car 1, this one car 2, this one has no initial velocity in the x direction. So that goes to 0. So it's just the velocity of this one times V2 initial in the x direction has to be equal to P final in the x direction. This is M total times V final in the x direction. We do the same thing here for the y direction. This one's going to be 0, so we only have this car. So this is going to be M1 times V1 initial in the y direction equals M total times V final in the y direction. So we have V final in the x direction is M2 V2 initial x over M total. And over here, V final in the y direction is M1 V1 initial in the y direction over M total. So this one, M2, is 1700 kilograms. V2 initial in the x direction, 12 meters per second, negative x. So negative 12 meters per second. And then M total, 1700 plus 1500, 3200 kilograms. So V final x, we can get from that. Same thing here. M1, so 1500 kg times V1 initial in the y direction. This is 8 meters per second plus y. 8 meters per second over 3200 kilograms. So V final in the x direction is negative 6.38 meters per second. V final in the y direction, 3.75 meters per second. And that's positive. So we have the x and the y components now, but we're actually looking for the speed and the direction. So the speed we get using Pythagorean theorem. So V final is the square root V final x squared plus V final y squared. And theta is inverse tangent of V final y over V final x. So this is 7.4 meters per second. so if I put those in, I get theta equals negative 30.4 degrees. Remember, zero angle is in the positive x direction, so negative 30 degrees means it's going down this way. That can't be right. I'm sure it's not right. That's what my calculator told me, but remember, you can't always trust what the calculator says. So the way I like to do it, I'm going to draw a triangle in here and say, okay, this one, this is the y, 3.75, this one, 6.38. It's in the negative direction, so that's shown by just the fact that it's this way. So now I can say inverse tangent of that angle is 3.75 divided by 6.38, which is going to give me again 30.4 degrees, but this time positive, and this time I know this is the angle that from this direction, from west, it's going north from that. So I am going to call this angle 30.4 degrees north of